Hi everyone. If you are a professional learner in generative AI and have been following Datahat, you would know that numerous powerful large language models are being released in the generative AI landscape on a daily basis. Some of these large language models such as Llama 2, ChatGPT, GPT-4, Gemini, we already discussed some of them in our earlier videos, and in this particular video we are going to talk about a very powerful and a unique large language model that is gaining widespread popularity in the generative AI community. This model is so powerful that it has beaten Llama 2 70 billion model on various benchmarks and has a 6 times faster inference rate. Most importantly, it is an open source large language model. Therefore, we as professional learners need to know about what makes this model so unique and so powerful. You are watching Datahat. If you're new to the channel, make sure to subscribe now and hit that bell icon to never miss a video and stay on top of your generative AI learning. The Mixtral 8x7B model, which is released by Mixtral AI, is based on a unique architecture known as mixture of experts. So in order to truly understand what mixture of experts architecture mean, let us recall our GPT architecture. So in a GPT architecture, as you can see in the image here, we have two primary components in each decoder layer. The first component is the masked multi-head self-attention layer, and on top of it we have the feed-forward neural network layer. Now these two components comprise a decoder layer. As we want to scale our GPT architecture, we add more and more decoder layers stacking on top of each other in a vertical fashion. Thereby GPT-3 has X number of parameters, GPT-4 will have X plus Y number of parameters, wherein these incremental increase in parameters is based on the number of decoder layers that we assign. Now, what essentially happens as we keep stacking these layers vertically is that the compute time, or basically the inference time of these models, increase drastically. At the same time, these models become compute intensive. Say for example, a Llama 2 model which is 70 billion parameter will require at least 140 GB of RAM just to load the model for inference. By standard mathematics, a model with X billion parameters will require 2x GB of RAM for inference. Now, what mixture of experts does differently is, instead of stacking the layers vertically and increasing them correspondingly, it allows parallel sublayers in the feed-forward layer. As we can see in the image here, what essentially happens is, after an attention layer, we have a feed-forward layer which is having multiple parallel sublayers. Now each of these sublayers are connected together using a router, and this router determines which token will be processed by which of these experts. Now each sublayer is referred to as an expert, and it is architected in such a way that each expert or each sublayer trains or learns a unique characteristics from the data that we are training on. So what essentially happens is, a token, instead of being processed by all the layers that are stacked on top of each other vertically and increasing the number of parameters, we essentially divide the processing between sublayers or experts, right? So for example, Mixtral 8x7B, it uses two experts for each token in order to process the output, right? So just understand it this way. Now if we are parallelly adding together more number of layers, parallelly adding more more sublayers, what essentially we are allowing the model to scale, while at the same time the inference time of the model is not increasing rapidly or not increasing in a subsequent fashion, right? So for example, a Mixtral 8x7B, though by the name you would assume that it has 56 billion parameters, but in reality it has only 47 billion parameters. Now each token in a Mixtral model, again talking about numbers, each token in a Mixtral model is only computed with about 13 billion parameters, which are known as live parameters. So it goes as, whenever a token is supplied to the model, The router decides which of the experts that it has to process that token. So currently in the Mixtral model, we have 2 experts processing the model out of n number of experts. Only for a token will be passed only for these 2 experts, while all the rest of the sublayers will be idle, will not be utilized. So therefore, only 2 experts would be live at any given moment, and thereby your speed up would be drastic. The rest of the components of the Mixtral or mixture of experts architecture remains as it is. We still stack layers, but the number of layers that we stack is correspondingly much lesser than compared to the number of layers that we stack in a GPT architecture. So if we talk about comparative study, a Mixtral 8x7b model, which is having 47 billion parameters, has beaten Llama 2 70 billion parameter model on multiple benchmarks. So this is making it so powerful and so unique. And at the same time, it has 6 times faster inference rate than Llama 2 70 billion parameter model and various other models as well. Now, understand it this way. When Mixtral inference is compute bound at large batch sizes, we expect a 3.6 speed up relative to a dense model. So this is what the calculation shows. We have nearly 3.6 times of speed up when we are talking about a large batch size or compute intensive task, thereby making Mixtral model so powerful. So a Mixtral 8x7b model has a speed or inference time which is corresponding to a 13 billion parameter model. This is what makes it so powerful and so unique. Hope you understood the concept behind mixture of experts and how Mixtral 8x7b model is working. If you learned something new and found the content useful, make sure to give it a thumbs up. See you in the next lecture. Have a nice day. Bye bye. Jai Hind.